to write stuff down. It's helpful to write it out of your book. Anyways, we're going to do transformation of functions. For example, number 1, they give us this graph. And basically in the graph, let me read what it says. It says, first graph, g of x, which equals a of x, where the parameter is a equals 2. So they're asking us, they want us to graph g of x, which is equal to a times the function f of x. Okay. And then they say, well, let's let a equal 2. So I'm going to write this in a different color. So we'll say let a equal 2. So then g of x is equal to 2 times f of x. All right. And so what's on the graph right now is f of x. So the easiest way to do this, so transformations are going to be things that we do. So remember, when we started this whole thing, we were focusing on having data and making equations that fit the data. And so the reason, and I don't know if you guys remember that one example I made up off the top of my head about making jackets. Notice that Mr. Adams almost right from the top of my head, like moved the graph exactly where I wanted it to go. Remember, we started off with a parabola, and then Mr. Adams said, well, what if we change this number? What does it do? And what if I change this number? I was transforming or fitting the model to what I wanted. So what we're going to do is we're going to write down the x values, then we're going to write down the f of x values, and then we're going to calculate the g of x values. Okay. So I'm just going to go through the points here. This first point here is -1, -2. So in that particular case, when x equals -1, f of x equals -2. So think of this as x, comma, f of x, right? You're used to seeing x, comma, y. But now we're going to start saying f of x. So now the next point occurs. What's this point? Can somebody help me with that? 1, 2. Very good. What's the next point? What's this one here? Yep. So that would be 3, -2. Good. And then this last point. 5, 2. Good. Okay. So those are the points on the graph. We have -1, -2, 1, 2, 3, -2, 5, 2. What did we say g of x was? Well, it's equal to 2 times f of x. What's 2 times -2? -4, right? You see that? So what I'm thinking in my head, I'm just kind of multiplying by 2. So I'm going to take all of these and just multiply them by 2. I don't know why I whispered that. So this one becomes +4. This one becomes -4. And this one becomes +4. So that means for it, and then next they want us to graph g of x. So when x equals -1 for g of x equals -4. So the first point for g of x is here. So that would be like -1, -4. So I'm just taking this value here and this value, and that's my x, y. So when x equals 1, what does my g of x value equal? 4. So I'm going to go over 1 and come up 4. Okay. And I'm going to draw a line from here to here as best I can. It's kind of hard to do on this tablet, but okay. And then when x equals 3, my g of x equals -4. I'm going to draw a line from here to here. And then when x equals 5, g of x equals +4. So now if I were to make some sort of general rule about a, what would you say a does to the function? I would say a stretches or compresses, right? Because a was 2, it looks like it took that whole f of x and just stretched it, right? Looks like I had f of x, and when I multiplied by 2, it just stretched it out this way. Does that make sense? What do you think would compress it? Yeah, you're right, but when we say divide, we multiply it by a fraction. So if a was between 0 and 1, you would be dividing it, sort of. Yeah, and that would compress it. And that makes sense. Our x values are the same in all these, but our y values, if we multiply them by a number greater than 1, it gets bigger. If I multiply them by a fraction which is less than 1, it gets smaller. Okay? Does that make sense? All right, let's do they want us to do the same thing, but now they want us to I'm going to move this out of the way here. The next thing they want us to do, I'm going to draw another box. Let's see if that's right. So same thing, let's write the values in. We know what f of x and g of x are, but let's do another function. Let's say that h of x is equal to 1/3 of f of x. So we're going to write these same values down that we wrote before. So this would be x. This is f of x. And then over here, we're going to do h of x. Okay. Now your textbook says g of x, but I'm going to... So in this particular case, a is between 0 and 1. Actually, yeah, you can't read that very good. Okay, does that make sense? All right, so let's rewrite those values down, and then we'll multiply by 1/3. I might actually change the values to something else because I'm going to change them to 1/2. So just erase this real quick because it makes for easier graphing. So over here, instead of multiplying it by 1/3, let's make it 1/2. Okay. So the grid is still the x and f of x doesn't change. I've got -1, 1, 3, and 5, -2, 2, -2, and 2. But now what am I doing? Now I'm multiplying by 1/2. which is like dividing by 2, right? So I'm going to multiply all of these by 1/2. So what's 1/2 of -2? -1. What's 1/2 of +2? +1. What's 1/2 of -2? -1 and 1. So now when I go to graph these, we're going to graph these points. This one is going to be here. This one is going to be here. This one is going to be here. And this one's going to be here. All right, those are all the points. So let me make those real big. And then we just we connect the dots. So when a is greater than 1, so let's not forget to write that down. So over here, someone say a is greater than 1. It'll stretch it, right? Because I'm multiplying that y value, it stretches it out. When I multiply by a fraction or a number that's trapped between 0 and 1, it compresses it, right? So this one, really technically, this stretches. And when I say stretch, I mean that vertically. So we're going to say stretch vertically. And when a is between 0 and 1, it compresses vertically. Okay? What do you think of that? So that's basically it for I actually, you know what, I did example 2. That's technically example 2, but we'll just call it example 1. Okay? Any questions on that? So if you're